Hey everyone, sorry for the delay. We are having a little bit of technology issues on our end, but we're going to go ahead and get started. So good afternoon and welcome to today's webcast titled Ahead of the Curve, Implementing Green Infrastructure in Rural and Growing Communities. This webcast is sponsored by EPA's Office of Wastewater Management. My name is Emily Halter with EPA's Green Infrastructure Program, and I will be moderating today's webcast along with a few of my colleagues. Thank you for joining us. So before we get to our presentations, I'm going to go over a few housekeeping items as usual. First, we'll have a question and answer session at the end of today's presentations. To ask a question, simply type your question in the questions box on your control panel and click the send button. If your control panel is not showing, click on the small orange box with the white arrow to expand it. You don't need to wait till the question and answer session at the end to submit your questions. We'll try to answer as many questions as possible. However, due to the high number of participants, not all questions will be answered. Please feel free to contact the speakers after the webcast, and we've provided the speaker contact information at the end of the presentation. If you have technical issues such as audio problems like I did earlier, please call the GoToWebinar support number listed on the screen here and give the assistant our conference ID number, also listed on the screen here. And a lot of times folks ask when we're going to post the slides. So the slides will be posted within a few weeks on EPA's Green Infrastructure website. That's epa.gov/green-infrastructure. And we have a whole new website. We just migrated to a new website, so please go on our website and check it out. And lastly, we'd like to remind you that the views and materials presented by our speakers today are their own and do not necessarily reflect those of EPA. So today we're going to be talking about the use of green infrastructure in rural and growing communities. As you know, green infrastructure is often framed as an approach to improving communities and addressing water quality in large urban areas where high concentrations of impervious surfaces can result in large volumes of stormwater runoff. However, green infrastructure can provide multiple benefits for small growing communities and communities in rural areas. So green infrastructure is useful for everyone. This webcast will showcase two such communities, Monona, Iowa and Clarkesville, Georgia, that are really ahead of the curve in using green infrastructure to address some of their stormwater management challenges. So with that, I have the pleasure to introduce our first speakers, Dan Canton and John Biederman. Before I do that, I'm going to just go ahead and pass the screen to them. So Dan Canton is the City Administrator of Monona, Iowa. He is a board member of the Turkey River Watershed Management Authority in Northeast Iowa and is currently in the process of developing a stormwater management ordinance for Monona. Dan is a 1976 graduate of Luther College in Decorah, Iowa. And also presenting with Dan is John Biederman, and he is a civil engineer and branch manager of Fairgraham's West Union, Iowa office. John graduated with a BS in civil engineering in 1991 from the University of Iowa and has extensive experience with permeable pavers and stormwater management. So Dan and John, are you on the line?
We are.
Okay, wonderful. Yeah, sorry about the technical issues earlier, but the floor is yours. Go ahead and take it away.
Okay, thank you, Emily, and thanks everyone for participating. As Emily mentioned, my name is John Biederman, and I have Dan Canton, City Administrator with the City of Monona, here with me. Together we're going to talk about the Aquatic Center Parking Improvement Project that we completed with the City of Monona. Not a huge project by any means, but that's maybe kind of the point of our presentation. This is a project that really can be replicated in any community across the country, large, small. Same template we use can be used anywhere. So looking forward to sharing with you this project. Just for some background, City of Monona is located in Clayton County in the far northeast corner of Iowa. Smaller community, rural community, population of about 1,550, about 675 households. So just a traditional Midwest rural community. And here, showing an aerial photo of the community, just to kind of give you a scale. This isn't a large city. Area of the community about 1.2 square miles. As you can see, we got a lot of rural area, farm ground around. Our project, you can kind of see my pointer located here in the southwest part of the community, kind of a newly developed part. And we'll get into the aquatic center. Constructed in 2004, it's a popular summertime destination for not only the city of Monona, but the surrounding communities, surrounding rural areas. You can see from the photos, it's top of the line recreation area. Definitely has a positive economic impact to local businesses, get a lot of visitors to the community. Just city did a super job of getting that facility constructed. But along with that, it appears that maybe the parking lot was kind of an afterthought and maybe budget was a little lacking. So it ended up just being crushed stone surfaced. Maybe not the greatest thing when you've got people walking to an aquatic center to get out of their vehicle, walk across crushed stone. Very steep access drive, 10% plus, fairly unorganized parking. At most, they could get 25 to 30 cars in there, and it wasn't delineated in any way, so the first people that showed up kind of set the tone for how vehicles parked, and it was randomness at best. And then along with that, had a fair amount of erosion to the adjacent street, storm sewer, and to Silver Creek. As you can imagine, from a steep slope with everything shaped to drain right down the driveway, which you can kind of see there in the lower right onto the street, and causing issues with the downstream areas. And here's an aerial, kind of a blow up of the aquatic center, and then you can see the parking area kind of in the middle to the top. Just looks ugly from that photo, and it was even uglier when you actually saw it in person with the steep driveway and the crushed stone surfacing leading up to really a beautiful facility otherwise. So the city was looking for opportunities for improvement of the parking lot. As most of you are aware, there's few, if any, grant opportunities for traditional hard surfacing such as asphalt or concrete. There just aren't grant sources for, especially to do a small project like this. So the city had been struggling just to find funding to make improvements. Along with that, the city of Monona is a member of the Turkey River Watershed Management Authority, and the authority is a strong advocate for flood reduction and water quality improvements. The group got started 4 or 5 years ago. Through presentations, meetings, the city became more aware of and more focused on the importance of stormwater management, flood reduction, and water quality improvements. Traditional surfacing, as we know, does not offer any flow reduction or water quality improvements. Traditional surfacing is just good at getting stormwater to run off really fast and carry pollutants with it onto the downstream area and increase flooding potential. The city, along at the same time here, was funding a wastewater treatment plant improvement project through the state revolving fund, and the state of Iowa was looking for ways to improve stormwater quality and runoff quantity through the state, and put together what was referred to as a sponsored project that goes along with that wastewater project. And basically the financing for the wastewater treatment plant loan that the city had is restructured to provide funding for the stormwater quality project at little or no additional cost to the city. And we'll, later on here, we'll run through the financials on this project so you can see what this actually did cost the city. The city chose to pursue this sponsored project funding opportunity. As part of that, a stream assessment is required for the local receiving stream. And as luck would have it, the local Clayton County Soil and Water Conservation District had completed that assessment previously. They had identified and targeted Silver Creek for improvements to water quality, so some of that work had been done. Once we realized that, then we looked at other options or options in general for stormwater quantity and quality improvements to the site. We looked at things, traditional green items such as bioretention, maybe even just stormwater detention basins, and also some surfacing options. After kind of looking at those, the site, using our knowledge, the permeable paver surfaced parking lot rose to the top just for a variety of reasons. We then prepared an opinion of probable cost for the permeable pavers in the parking lot with 45 parking spaces, knowing that we could scale this up or down depending on how the bid price came in. But we started out with 45 spaces, and that opinion of probable cost matched up very closely to the available sponsored project funding, and we'll get into that here in a couple slides. So everything was looking good. The city prepared the sponsored project application and ended up getting that approved. So once we were approved, then we started in on design. Some of the design goals we were looking at for this project was to maximize the funding source eligible items. As many of you are aware, each grant that you apply for and receive will likely not fund everything within the project. It'll be targeted towards specific items. In this case, this was a stormwater quality grant, so we were really targeting features that would improve stormwater quality and quantity. So we have a parking lot. Most parking lots have a sidewalk that goes with it. We want to maximize the eligible items, so we are looking at permeable surfacing for the sidewalk and parking lot both, really as much as we could possibly get in. Also, stormwater quantity reduction, so we're looking to provide as much storage volume as possible for stormwater management. Water quality improvements, that was one of the main goals of the grant, so obviously that's a main part of the project. Native soils were fairly impermeable. We have clay here in northeast Iowa, so there's little infiltration through those soils, so our design needed to match what we have, and we'll get into that here in a little bit also. Talked about the driveway being very steep. Also, the parking area was very steep, 7 to 8%. So, you guys that are familiar with steeper areas, it can be a little unpleasant. So we were looking at flattening that slope out as much as possible. We talked a little bit about the unorganized randomness of the parking spaces. So main goal here was to maximize the number of parking spaces within the parking lot footprint, and then also improve pedestrian accessibility, whether it's getting from their vehicle to the aquatic center. We just wanted to make it more accessible. Stormwater goals, drill down into this a little bit. We want to treat stormwater. So not only the standard pollution types of petroleum, antifreeze, heavy metals, sediments, the things that are on vehicles and fall off vehicles in a parking lot, but also thermal pollution, and that's if we had a asphalt, for example, surface parking lot, gets very hot in the summer, 150, 160 degrees with the sun beating down on it. We get a quick thunderstorm, quick runoff, and we're discharging to a smaller stream. We can have very warm water entering that stream and really could cause some environmental damage to that stream. So can we cool that water before we discharge it was another goal. Reduce runoff rate and promote infiltration, realizing we had a fairly impermeable clay type soil. So we knew infiltration wasn't going to be wonderful, but still we want to promote as much as possible. And then be a model for the city of Monona residents, the Turkey River watershed, and the state of Iowa. This is somewhat of a newer technique, so we really wanted to kind of be a showcase project for the area. And here's a slide of how that final design ended up. And got a lot of stuff going on here, but I just wanted to point out a few things. Got the aerial photo of the pre-project on, so you can kind of see the footprint of where that crushed stone parking area was. And then you can see our line work of the finished parking lot. So you can see we're actually in a smaller footprint than what was originally there for parking. And we have 45 parking spaces. So we have easily increased 15 to 20 parking spaces over what was there before in a smaller footprint. So we accomplished our overall goal of an efficient parking area. Also, you can see the driveway, the very steep 10 to 15% driveway has been eliminated, and we moved that over to the other side, the other street, and we went from 10 to 15% down to about 3%, so made it much more pleasant for vehicles getting in and out. And then onto the stormwater portion, everything you see there in the parking lot and the sidewalk just on the southerly or bottom edge of the parking lot is permeable pavers. So those are infiltrating every drop of water that falls onto that area. And we'll get into the details. We've got a bunch of construction photos that you'll really get to see how this all works. But the permeable pavers are made out of a high-strength concrete, so we're not getting any infiltration through the paver itself. It's all through the joints that are between the individual pavers. And once it gets through the paver joints, it moves into a crushed stone base. And at the top of the screen, you can see a cross-section of the project with our pavers on top. The bulk of the area we're running with a 24-inch thick crushed stone base, with 18 inches of that being larger stone, 2 to 3 inch diameter, and then the upper 6 inches being 1 inch diameter stone. And this is clean washed stone, 40% void. So 40% of that volume can be used for storage. In our case, we have a fairly steep slope. You know, we talked about 7 to 8% before the project. We were able to get it down with the new project in the 3 to 5%, but still a fair amount of slope. As you can envision, any water going through is not going to sit on a slope of that magnitude. It's going to run to the lower end. So knowing that, knowing we didn't have sandy soils that infiltrated real well, we designed a deeper reservoir at the lower end. So you can kind of see that at the left-hand side. That's 5 to 6 feet deep, and that was sized to hold close to the 100-year storm for this area with zero discharge or zero infiltration. So we've got a lot of storage volume there. Anything that hits this parking lot is going to drain through the pavers and get down into that lower storage area. We then put in or designed knowing that we had very little infiltration from native soils, we designed a tile under drain through that reservoir. We have it just off the surface, 6 or 8 inches. And then that is tied to an outfall line that you can see goes off the upper end and ties into the storm drain system. That's to provide a slow, managed, controlled discharge versus just allowing it all to run off at a high rate. The one thing we did here is added a gate valve onto that outfall line so we can really dial that down to discharging next to nothing. And we'll talk about that quantity here in a little bit. So kind of gives an overview of what we have. We had to do a little bit of grading, add a little retaining wall in the far corner just to get a logical footprint for the parking lot. But overall, that's what we have. Stormwater runoff, these are some of the quantities I talked about. Before the project or the original condition, 5-year storm, we're getting about 3.2 cubic feet per second off from that site. With the 100-year event, where we jump up to about 6 cubic feet per second. So may not seem like a huge amount, but realize we're not a real large parking lot here, about 1,900 square yards. So still, you know, that's a high runoff rate, and from the small confined area, it's a large shot all at once. It's through there, very quickly. So post-project with the new construction and the valve release for the 5-year and the 100-year, we have a variable discharge rate from essentially 1/10 of a cubic foot per second up to whatever that tile line can handle, which is still going to be a very low number. Currently, we have that valve closed down to where we're discharging that very low amount. So the runoff rate is really controlled as much as we can. And with that storage area that we built into the project, we can drain all of the runoff or all the rainwater that hits that area. We can stretch that out to about 4 days versus before the project or with traditional surfacing. That's going to be done in a few minutes. So you get that large shot that's through in just a few minutes time. Now we've taken that out to maybe 4 days for the 100-year event. So stormwater runoff rate, we've maximized that, and there's nothing there. So really worked out well. And now we'll get into some construction photos so you can really see what took place. Upper left, contractor has peeled off the crushed stone surfacing. You can see we're down to the bare dirt. Here in the lower right, you can see that outfall line tying into a storm sewer intake at the upper part of the photo. And then you can see that valve to really offer maximum control for the runoff rate. Here we're putting in the base stone. This is where the bulk of that storage takes place. This is 2 to 3 inch diameter clean crushed stone, 18-inch thick layer over the majority of the parking lot, 40% voids for that base material. Here in the lower left, you can see that storage trench or that storage reservoir being constructed. You can see the tile line there exposed. We're just getting the rock in to fill that up. You can get a good idea how deep it is after this. We still built up that far edge a little. So it's about 6 feet deep or so for the full length, and then for the width we needed to get that volume. And after that initial base material of the 2 to 3 inches placed, then we place a 1-inch diameter clean stone base to kind of choke that layer off. We used a 6-inch thickness, 4 to 6 is commonly used. This stone also is very close to that 40% voids and a little easier to grade. You can see that once they're done grading it, we have a pretty uniform surface. Once we had that done, contractor poured concrete curbs, and this is traditional construction. This is nothing new, nothing fancy, but we need those curbs as containment for the pavers. Without the curbs, the pavers can float around and we get into trouble. So we poured an 18-inch wide curb around the perimeter of the parking lot. And then in the lower left, you can see the sidewalk area and just getting some forming lined up to pour a narrow ribbon type curb to contain those sidewalk pavers. And we'll see the finished product here in a minute. Here we're putting in the setting bed, and this is maybe one of the more critical parts of the overall project. You can see where the uniloader is there. We're on that 1-inch stone base, and then they are pulling a wide screed, and a wide screed is very critical to this operation. The wider the better to get uniformity. And we're putting down 3/8-inch crushed stone chips. So that's what we're screeding out. You can kind of see that in the foreground. And the pavers will set right on top of this chip base. So the key here is to get this as uniform as possible. Whatever this setting bed profile and surface looks like is exactly what your pavers are going to look like. So any irregularities, they'll show right through. So that's where it's very important to have as wide of a screed as possible to really improve that uniformity. And the contractor here had a wide screed and really did a super job of getting that in uniformly. And here's a photo very similar to the previous one, but after we've put the pavers in the sidewalk. You can see the curb on both sides to contain those. We designed this to match the paver size exactly, so we didn't need to cut pavers, so it's a standard width across. And we used a couple different types of pavers on this project. What we're seeing here is a paver that is a little more uniform in texture and surfacing, a little better for pedestrians versus vehicles. A little tighter joint, but works well. It's a smooth surface. Really works good for pedestrians. And then you can see off to the right, we have that stone base. We're getting ready to be able to put the pavers down there. Pavers for the main parking lot were mechanically placed, so we're not putting those in one at a time by hand like was done years past. The pavers come palletized. You can see in the upper left we have a pallet there of pavers. And then the contractor had a machine that actually attached to a mini excavator. There's multiple types of those, but the principle is the same. It will grab a course off from the pallet just by compression. It holds them together. And then you can see in the following photos here, upper right, we just swing that across to where that goes. Lower left, dropping it into place. The machine releases pressure and they're in place. So we're doing that roughly 4 by 4 foot square, just one right after another. So it really goes pretty quick. If you had to put those all in by hand, it'd be kind of an unpleasant task, but goes really quick with the modern equipment. One thing we wanted to build into this project was to reduce as much maintenance as possible in a parking lot. You're all familiar with the time it takes to paint stripes, handicap symbols, no parking areas. It's an annual process. It takes a lot of time for public works staff. By using some of the different paver colors, types, textures that are available, we were able to eliminate that from this parking lot. And we used white colored pavers, bright white, for the parking stripes, and we're able to cut those in so they match in perfect. And that's a permanent marking for the parking spaces. Also in the upper right, you can see the handicap symbols were also cut in with pavers. We made that a requirement of the project, and the contractor did a super job of using some artistic talent to get those to where they really look good, and they're there forever. Also, we used a darker colored paver to delineate the no parking areas, whether it's a pedestrian access aisle or just an area that we're not wanting vehicles to be. So really worked out pretty slick, and something we try to incorporate into all our paver projects to really reduce that future labor by the Public Works Department. And here at the end of the project, after the pavers are placed, then we fill those joints between the pavers with, again, the same 3/8" chips that were used as the setting bed. And those are just scattered out loosely on top of the pavers, and then the contractor will go through with a broom, large rotary broom, which you can see in operation here, and just work those chips into the joints. And by filling up those joints with the chips, we are able to keep out dirt, sediment, dust, whatever particles will land on a parking area. It just helps keep that a little cleaner and more open. Not that there isn't future maintenance with vacuuming and cleaning, but really helps out in keeping that overall system operating like it's designed to. And then here's a photo of the completed project. So I think everyone would agree that's a huge improvement over what we started with. In the foreground here, I wanted to point out we have some traditional concrete for sidewalk, but then adjacent to that we have a flatter area that we use for bike parking. So there's a bike rack on that now. trying to promote healthy lifestyles. So, as many kids as we can get to ride a bike to the aquatic center, that's the more better. So we need to provide a place for that. We're able to use the pavers as a base for that area. As far as maximizing the eligible items, I thought we did a pretty good job of that. The only thing here that was not a grant eligible item was the dumpster pad and fence, which you can see in kind of in the far back of the photo. We were not able or were not willing to use pavers for the base for the dumpster pad, knowing that that takes a tremendous amount of abuse. But it all worked out in the end, and Dan will go over some of the financials here, and you can see how that worked out. But overall, pretty much everything was able to be grant eligible in this project. Got a video here, and we're going to give this a try. I know in our practice run it didn't work out the greatest, but it's just a YouTube video. I got the address there at the bottom, so go ahead and copy that down in case this doesn't work out real well. But what we're showing here is a 2,000-gallon fire truck on the site, and we all dumped that 2,000 gallons in 2 minutes or less, just to see how the pavers actually work. So I'm going to give that a shot here, and we'll see what happens. This is about 40 seconds in length. So if you're able to see that here, we're showing that 2,000 gallons being dumped. It disappears over about 3 widths of parking spaces. So that's about 30 feet. We're getting all that water down through the pavers and into that base where it can be handled. So, you'll see that black thing there that we're dumping water on. The city tried this the first time without that, and we blew all the aggregate out of the joints with that high discharge rate. So we dropped a rubber mat down just to kind of dissipate some of that energy. And if you weren't able to see the video, I have a photo up here now of the same thing, just showing that water really disappeared quickly. Advertised rates for pavers I've seen up to 150 inches per hour. If any of us ever see 150 inch per hour rainfall event, we're probably in a lot of trouble. So it'll handle pretty much anything, as you can see here. And then once we're done, with any project, we need to celebrate the success of it. The city held a ribbon cutting event for not only citizens of the town, but also state staff that helped with the project funding, the local soil and water conservation district, and all of the partners really with the project. We had the contractors there. Myself was there. So really nice event to really showcase this project once it was completed. And this ended up being the first SRF-sponsored project to be completed in the state of Iowa. So we were right there at the beginning of that program. We have received a couple of awards on this project. 2015 Iowa Water Conference Stormwater Award, and then we recently were notified that we received a 2015 ACEC Iowa Engineering Excellence Honor Award in the Special Projects Division. So good recognition for the city for this project. Just want to go through the process summary a little bit on kind of how we put this all together. Initially, we talked a little bit about this. We identified the partnerships to make this all happen with the funding source, and that ranged from the district, obviously the city themselves. Also, we had assistance from Northeast Iowa RC&D with some of the applications and just overall advertising of the project. We made the application for the sponsored project, received approval, and whether not every state is going to have this sponsored project, but I know some have similar. But there's other grant sources also, so we can, you can plug in whatever grant source with the sponsored project. It may be an IDOLS, CDBG, there's other grants that fund this type of project, but the process is pretty similar with all those. We ended up with urban conservationist review of the project, which is a requirement of the sponsored project. Prepared preliminary plans, had the council review those. We updated our cost estimate. Everything was pretty much on track through that process. Prepared the final plans and specifications, received final approval from the city and the funding source. We were then able to hold a bid letting, go ahead and construct the project, had our local celebration as you saw, and then project closeout. So pretty standard with a public infrastructure project. And then here we've got a couple slides that outline the financial component of the project, and I'm going to turn it over to Dan to kind of run through this.
Thanks, John. I'll talk briefly here on the financing end. As John mentioned earlier in one of the slides, this project was done in conjunction with the wastewater treatment plant loan that was established. The initial clean water loan amount, as noted here, was $2,603,000. That loan was set up at 1.75% over a 20-year period. By being involved in that loan, that made us eligible for the sponsored project. And after submitting our plans and specs for that, we were fortunate enough to be involved in the project. So approximately the way the Iowa DNR program works with the sponsored project is the $245,000 is between 9 and 10% of the actual final loan for the wastewater plant. So when looking at the amount of money we had available for the parking lot, it appeared we initially had approximately in that $240,000 to $50,000 range. So the way the financing worked with this is the loan amount is increased from $2,603,000, adding the $245,000 to $2,848,000. So the debt is increased. However, as noted here, the loan is restructured by lowering the interest rate 1%. That keeps the annual debt service payments the same. So had we not done the project, our debt service would have been the same. So it's like getting a second project funded for the same amount of money. And then the actual project itself, again, the engineering for the parking lot was approximately $30,000. General contractor, Bacon Concrete, did all the construction work for $230,000. The total project was just under $261,000. Again, this represents about a little over between 9 and 10%. That's where the $245,000 comes in. So after receiving the funds to make those construction engineering payments, the city's actual share was $15,900. There was an SRF loan origination fee, and there's also some bond counsel fees, which are lawyers that draft appropriate resolutions and paperwork to meet the Iowa code. Anyway, the net cost of the city was just under $20,000, and obviously the city council was very pleased with doing a project like this. One is we couldn't probably not make any parking improvements at all without some kind of funding source. And John and with Fair Graham did an excellent job in design and keeping our costs pretty close to what we could handle. And we didn't want to eliminate or reduce any of the design elements. We kept it right where we wanted to be. And again, City Council was pretty pleased that with this kind of investment. Okay, so we talked about that project and how successful it was. So now we're on to the next project, Bulldog Boulevard. And this is a street that is directly adjacent to the Aquatic Center. The new access drive actually comes out onto Bulldog Boulevard. You can see in the lower left the new parking lot, the new drive, and then you can see a crushed stone street. So we have a 650-foot length of crushed stone, 24-foot wide street currently.
obviously it sees the traffic to the aquatic center. It's also a street to a kind of a newly developed commercial industrial area. So the city sees more and more traffic here. It's probably the last crushed stone surface street in the community. The city council has had it on their 5-year plan to improve for a while, but again, lacking funding for that type of a project. So along with the city's wastewater improvements that they're making, the next phase after the wastewater plant was some collection system improvements. So they have a revolving fund loan for that as well, which makes them eligible for another sponsored project for water quality improvement. So we've been through this process the second time and have been approved for funding with the sponsored project to reconstruct this street, Bulldog Boulevard, with permeable pavers. And that is proposed for 2016 construction. And seeing some of the same issues here, you guys all know what a crushed stone street is like, but steeper slopes, a lot of high erosion potential, as you can kind of see in the upper right. You can see where that stone is washing out onto the surfacing. So with with the tremendous success we saw from the Aquatic Center project, we're just moving that into the next phase, and now with a street versus a parking lot. Here's again back to that overall, and I've outlined there with the oval the portion that we'll be looking at with the next project. Also, as I mentioned, this is kind of a newly developed area for industrial and commercial. Lower part of the screen there, you'll see some open area that the city is marketing for development. And by getting this section of street finished off, we're just improving access and really should spur along development of that area. Along with this, we've educated the local residents of the importance of stormwater management, and really in a tangible way that they can walk on, they can see. The city is moving towards developing a stormwater management ordinance and really making any future development have some form of stormwater management. I'll let Dan speak a little bit on the city's thoughts there.
Yeah, the city council's in the process of looking at other ordinances that other cities have in place. Again, as mentioned in a previous slide, council understands the importance and benefits of controlling stormwater, not only the downstream flooding aspect, but also preventing sediment loading into the adjacent watersheds and tributaries, and of course water quality, etc. So had we not been involved in these projects, we probably wouldn't be moving forward with stormwater management.
So, and to wrap up, just a few important takeaway lessons here that I wanted to run through. Parking lots and streets of this scale exist in all communities. As you can see, these are not large projects. Any community I've ever been in has had a parking lot of this size. So you don't need a huge project to make this happen. It'll work for anything you can imagine. It'll work for. And these opportunities for green type reconstruction really exist everywhere within your community. An important thing to consider is to be open to new project types. It really opens up opportunities for funding. As we discussed, traditional construction methods, asphalt, concrete, very limited in funding sources that can be acquired. But if we think of these new types, permeable pavers, things such as that, it's amazing how many funding sources really are available for that type of construction. And yes, I hear all the time, well, those projects are more expensive. And to a certain degree they are, but the opportunity for funding is much greater. So as you can see, the city obtained a $250,000 project only costing them $20,000, which they could not have done with any type of traditional project. Educate the public. Stormwater management was a new concept in Monona. It wasn't something that was talked about or thought about. But having a successful, attractive project builds excitement within the community, within the residents, and gives support for the next project. I know in the first meeting that I attended with the City Council to discuss a permeable paver parking lot, I received some funny looks. Why would we want to do this? But when it came time for the next project, Bulldog Boulevard, it was nothing but positive response. Permeable pavers are traditionally used over native soils with a high infiltration rate. We didn't have that here. We had a fairly tight clay, but as you can see, with some special design considerations, we can make it work. It will work. And the construction techniques are basic, nothing unusual. As you saw in the slides, we just need to put them together, the various components, and turn it into the overall project. Okay, so with that, that wraps up our presentation. Thank you, everyone.
Thanks, John and Dan. That was a really great presentation and a really great example of a successful project that's leading you to another project. So thanks so much for sharing. I'm going to go ahead and run a poll of our audience. I'm just going to send that out now, and then we'll get on to our next presentation. Okay, thanks everyone. I'm going to go ahead and close the poll. Thanks everyone that voted. And now I'm going to change to our next presenter, Duncan. So let me bring him on the line. So like I said, I'm pleased to introduce our last speaker, Duncan Hughes. Duncan is the Executive Director of the Soquel River Watershed Association, or SRWA. SRWA's mission is to work together with individuals and organizations to protect and restore the Soquel River and its tributaries and watershed. Duncan has worked with the SRWA since 2004 on projects and programs to reduce or eliminate non-point source pollution. His primary goals are to educate citizens about threats and challenges to our waters and to engage them in the practice of watershed protections. Hey Duncan, are you there?
I am, Emily. Thank you.
Okay, well, we're glad to have you, and the floor is yours. Go ahead and take it away.
Appreciate the opportunity. Today with this talk, I'd like to give y'all a little bit of background for some context on how we got into green infrastructure and why we're doing what we're doing, how we've evolved and grown into green infrastructure, some examples of some of the projects that we've implemented locally, and finally some outcomes and some recommendations, general recommendations that perhaps you can use in your communities to implement some similar strategies to better manage stormwater. Hopefully now you're looking at a map of the state of Georgia, which also shows Habersham County in yellow. Clarkesville, the little red area, polygon on the right-hand side of the screen. And you'll also see the Soquel River watershed. That's the dark blue outline and the streams and the river within.
The Sequoia is about 160 square mile watershed, and Habersham County obviously is important. It's important to Habersham County as a local drinking water supply. It's also a recreational fishery. State record rainbow trout came from the Sequoia, looked more like a pig than a fish. It's important for recreation, drinking water, and it also provides about 1/6 of the inflow to Lake Lanier, which is very vitally important for the metropolitan Atlanta area and also our friends and neighbors downstream in Alabama and Florida. So the Sequoia is the northeasternmost tributary to the Chattahoochee, and many of y'all are probably familiar with the ongoing Apalachicola-Chattahoochee Flint conflict over the use and sharing of the resource. It's been a little bit like watching kids fight over a toy, but with more severe consequences. Here's another map of the Sequoia River watershed. The colored polygons you see there are sub-watersheds of the Sequoia. You'll note that actually since 2002, but up to as of 2008, we had 4 stream segments that did not meet state water quality standards. Those are the 303D listed streams. There are 2 contiguous on the Sequoia River that you'll see here with my pointer. One ends right about there at Clarkesville, and the next picks up on down to the confluence with the Chattahoochee River, and also 2 segments on Hazel Creek. And those are for pathogens and also excessive sedimentation affecting biota. Those are ubiquitous threats and challenges. You see them all over the state of Georgia and in fact nationwide. Because of those threats and challenges and the recognition that we were rapidly growing, developing community and would expect to see more stresses on aquatic systems, we started a watershed partnership back in 2004 with the City of Clarkesville as the lead organization, the Sequoia River Watershed Association, North Georgia Technical College, Cooperative Extension Service through University of Georgia, and also all the other municipalities in Habersham County. Our initial focus was on agricultural projects to reduce pathogens in streams, primarily fencing cows out of creeks. So through a series of targeted agricultural best management practices, we were actually able to meet and attain water quality standards for pathogens in 2 of the segments. As any of y'all that have done this work know, pathogens, if you can find and reduce a pathogen source through targeted monitoring and prioritization of projects, you can see an almost immediate response in the stream. Sedimentation is much more difficult to address as it's a natural process, and even if we could find all the sources of excessive sediment, dirt roads, eroding stream banks, improperly managed land disturbing activities, and stop them today, it can sometimes take years for the stream habitat to recover. As we worked through those agricultural projects and started looking at some of the other causes of the impairments, it became very evident that stormwater played a critical role in the degradation of water quality in our watershed. Even in rural communities like ours, you think of stormwater as an urban problem. We may be out in the sticks, but we've got pavement and rooftops. Some of the impacts we've seen from stormwater include eroding stream banks, mass wasting where tons of sediment is input to our streams and rivers, ruining the habitat for some of those very large trout. Also, right down here on the right-hand side, that's not an amenity fountain in a subdivision. That's a manhole blowing up with inflow and infiltration problems from combined sewer issues, which is also a very big stormwater concern. And these are complex problems. It's not just stormwater that causes this bank erosion, lack of adequate vegetated buffers in the riparian zone, but all these things play in together, and stormwater is a huge component. When you think about the way we've historically developed, it's been to remove all the vegetation from a site, strip the topsoil, compact the subsoil, alter the hydrology. This looks like a beautiful spot for a home. And this is a generalization, and apologies for my clumsy attempt at PowerPoint animation, but that's the wrong way to develop. And we all know this, and we all know that we can do a better job, and we've started to take steps in that direction. Even if you develop with new development to better control and manage stormwater, however, retrofitting for the existing problems becomes quite a challenge, particularly where space is limited. The image I'm showing you now, thankfully, is not in our watershed or in Habersham County, but this is right down the road on the outskirts of metropolitan Atlanta. And you don't have to be a hydrologist to look at this image and understand that all that parking lot and rooftop is going to have consequences on aquatic systems if forethought and care is not given to how the site's developed and how post-construction stormwater is managed. Now, there's our big urban problem, and that's what stormwater has seemed to many for decades. But I'd like to show you a couple of slides of land cover in little old Clarkesville between 1974 and 2008. This is 34 years, and you'll notice the reds and pinks are urbanizing areas, not 100% impervious surface by any means, but places that do have impervious surface on those parcels. And if I click again to 2008, you'll see there's quite a bit more red and pink and a corresponding reduction in forested lands. When you look at it from percentage of land cover in that 34-year period, we've actually lost about 36% of our natural areas in the city limits of Clarksville and gained about 43% urbanization. And again, this is a small area, a small city in a community that has the potential to grow rapidly, but growth wasn't off the charts during this entire period of time. We've experienced some additional growth since 2008, but I don't have that data to show you. These land cover data came from the UGA Natural Resources and Spatial Analysis Laboratory. So the image you're seeing now is a stream that drains from downtown Clarksville. You can barely see the trickle of water in the bottom left-hand corner, but note the incised channel, the tree roots that are exposed, the bank erosion and mass wasting that's occurring. And much of that is due to the excessive volume of stormwater that comes from downtown Clarksville. This is a very small watershed, a 0.1 square mile watershed, but a very, very flashy system. Here's an aerial image of that small watershed. The green star is the location of the photograph that I just showed you. And you'll notice that a good deal of the upper watershed is made up of residential areas and also a commercial area in downtown Clarksville. When I pop the land cover on top of that, you'll see all those reds and pinks again indicating the urbanization. That small watershed is 64% urbanized, which is a very high number when you talk about treating the volume of runoff. Imagine the pre-development condition, what a 100-year rain event would produce in terms of runoff to that small stream, and then think about how the peak storm flow would change on a hydrograph with that much hard surface in a small watershed. So what we came to understand through all of this was that we needed to do a better job of stormwater management. And through doing that, we have built some demonstration projects. The picture you see in the bottom left, actually right up here, let's go to the top right. This is a large building, 280,000 square feet, which is the old Clarksville Mill in Clarksville, Georgia. And with our annual average rainfall of about 60 inches of rain a year, that would create about 10 million gallons a year of runoff that was previously straight piped into a small tributary to the Sequoia River. We broke the connection between those hard surfaces and the stream, and that's a lot of what green infrastructure is all about in a small community and in large communities, is getting away from the traditional collect and convey directly to receiving waters and to allow that water to infiltrate or evapotranspirate back into the atmosphere or infiltrate into the ground. There's just a low head dam with these weir notches that you see cut in here, and subsequently that area has been developed. This is on city property into a city greenway. Big old river birch growing up here, lots of wetland plant species coming in, and it's become a great, it's aesthetically pleasing, it's a highly used recreational area, a lot of wildlife benefits there, and it's not always possible to do projects like this due to space constraints, but in this area we had good soil for infiltration, the luxury of space to do it, and willing partners to work with it on. We also know that we need to demonstrate better stormwater management at multiple scales. So here's an example of a parking lot in front of a local business that was completely unneeded. You can see where it had been dug up there for the city to replace a leaking water line. And some of the city staff, through this long process of working through the agricultural projects and starting to consider stormwater management, actually came up with the idea to replace that unneeded asphalt with something that would allow for infiltration. So what we came up with was a bioretention area. This captures runoff from the roof and also some that travels down the roadway here and from this parking lot, and it's all routed into the bioretention area where we get infiltration, treatment by soil microorganisms prior to discharge. These types of best management practices do have to be carefully considered and evaluated. You can't just have a dude with a backhoe dig a hole. We had a state right-of-way here to contend with, and also the foundation of an existing structure. So we did have some engineering costs that were able to be funded through a 319 grant, and we've been partners with Clarkesville Watershed Association in a series of 319 grants over the years, and they've been very beneficial. So city staff did the work on this, and this builds capacity for them to be able to implement future projects where green infrastructure is appropriate. Boy, the picture you're looking at now, a tree grows in Clarkesville. This is a very sad picture, and it brings to mind me to ask the question, why is the tree there? Well, the tree's there because codes and ordinances require that a certain number of trees be planted for X number of parking spaces or square footage of parking area. But what's the real intent of having the tree there? Trees provide multiple environmental benefits, but we could be getting a lot more out of this sad little fella if we didn't have the curbing around it, if it had been engineered and designed to be more functional from a hydrologic standpoint, rather than to just be something that people end up running over and knocking their wheels out of alignment. How much better would it be if we could encourage something like this instead? This is not in Clarksville, but this is what we're working towards. This is at the University of Georgia in Athens, Georgia. But you can have stormwater features that are aesthetically pleasing, very much help restore natural hydrologic function, and sometimes I think our codes and ordinances have lost sight of the real intent of the reasons things like having those trees are in there. Another practice we promote is grass swales. This is really easy way to encourage better roadside stormwater management. Again, not suitable for all places. You need the space to have a broad U-shaped channel and not a narrow V-shaped ditch. This also can be cheaper than traditional collect and conveyance. You can see there's an outlet up here with a head wall. They could have piped this all the way down through this grass swale to a storm drain. They decided to open up and let it flow, providing some filtration, possibly some infiltration, but it's cheaper and it's easier to maintain, and we've been really happy with how these things work. Also note on the parking lot in the right-hand picture, absence of curbing, allowing sheet flow off of that parking lot into the grass swale area. We also constructed a new courthouse. Clarksville is the county seat. We constructed a new courthouse, which has been the biggest construction project in the city limits in the past decade. Again, note the absence of curb and gutter, sheet flow from the parking lot. In stormwater management, concentrated flow can be your enemy. If you can spread it out, you stand better chance to allow it to soak in. So we're putting it into this engineered, enhanced bioswale. Underneath the river stone you see here are amended soils, sands, and organic material, which help with soil infiltration and also absorption. Down on the end is an overflow mechanism, which sends this down to a constructed wetland for further treatment before it's discharged into a stream or a river. I'd like to also say a word about tree plantings. We don't maybe often give trees enough credit for the role they play as green infrastructure. This is at a local elementary school, and I've seen this time and again, not just in Habersham County or Clarkesville, but across Georgia and really everywhere I've been. It's an epidemic at schools. When we construct them, we spend a lot of time thinking about the physical facility, which is important, but we forget about how that facility fits into its landscape and into the natural environment. Here, you've got bare red clay. It's effectively like concrete from a hydrologic standpoint. No organic matter, nothing can grow on it. So how do you fix something like this? Well, it's not easy and it takes time. The best time to try and plant a tree, someone has said, was 20 years ago. The next best time is now. So what we did was get a whole bunch of chipped up leaf mulch from the city of Cornelia, one of the other municipalities in Habersham County and a great partner on these projects, and delivered that and planted some hardwoods in here. This is right after planting about 3 years ago, and they have started to grow and take off, and the idea is hopefully over time we start to build up that layer of leaf litter and organic material to allow better infiltration and more moisture being retained and eliminate some of the runoff problems. It's also just much more aesthetically pleasing. Through all of these projects I've showed you, we realized though that we really didn't fully understand our stormwater system. We didn't understand the infrastructure. We knew we had problems with the system through decades of piecemeal installation and repairs that really didn't have a plan. So what we did was contracted. This again was funded in part through a Clean Water Act 319 grant through US EPA and administered by the Georgia Environmental Protection Division of the Department of Natural Resources. Contracted with Ecological Planning Group to come in and do a GPS stormwater inventory. This is just one screenshot that shows some of the maintenance needs and structural damages and some recommendations for maintenance. And it's important to understand traditional stormwater infrastructure and what needs to be done to repair and maintain it, but it's also important to look for opportunities to implement green infrastructure when possible to replace those traditional mechanisms. So I was amazed to learn that there were this many miles of open ditch and pipes in our very small city, 5.6 miles of natural waterways. And what we found out through the inventory the Ecological Planning Group did, I'd like to thank Mike Baggett for that, is that we had a lot of features that had significant structural damage or were in need of maintenance. More importantly, from my point of view, is we did also through this process begin to identify opportunities to implement green infrastructure. And that's really the point that we want to get to. Here's a slide showing some of the things that Mike found, the Ecological Planning Group found when they were in the field. This is not going to work really well. A lot of sedimentation clogging up our pipes, leading to some flooding in some cases, debris jams and accumulations, and also erosion. Look at how the stream bank has receded over time, and that's causing problems not just for infrastructure, but for aquatic life and water quality downstream. So finally, through all of this, we've got some information on our stormwater system now, but we really wanted to be able to integrate green infrastructure into our planning and implement it to become the way that we manage stormwater, the way that we do business. We were fortunate to receive a Green Infrastructure Technical Assistance Grant through the Environmental Protection Agency, and the purpose of this grant is to help overcome barriers to the implementation of green infrastructure, common barriers. What we didn't have was the local capacity, and we needed some help with that. So the goal is to protect and improve water quality, and we did that through two main things: trying to look for locations to implement green infrastructure, and all this work was performed by Tetra Tech. Particularly like to thank Heather Fisher and Eric Byrne. they developed some fantastic conceptual plans for green infrastructure best management practices. And we also, very importantly, back to that really sad-looking tree in the parking lot, did a code and ordinance review and came out with some good recommendations for the mayor and city council to consider and city staff to consider to encourage green infrastructure going forward. One of the outcomes of the green infrastructure technical assistance from Tetra Tech was the ranking or prioritization of parcels in the city. The red parcels you'll see were evaluated based on a number of factors like publicly owned, the percentage of impervious surface, their infiltration capacity, what the existing soils were, proximity to existing stormwater infrastructure, percent slope. A number of other variables were considered and ranked, and the top 10 parcels came out to be locations where we could then actually further evaluate potential recommendations. We also went out and screened these at the site level using local knowledge and input from city staff to pick the best suite of green infrastructure BMPs. Here's an example of a conceptual plan that Tetra Tech developed for a green streets program. So this is in our highly impervious downtown area, the same little watershed that drains to that badly incised creek I showed you previously, which I used to call Stormwater Creek, but I found out its name is Sweet Gum Branch. I like it better as Stormwater Creek. But you got all these planted areas along the streets, and there's information in here. I don't expect you to be able to read that, but we got 10 of these plans that are concepts ready to go with a little bit of engineering and work from the city that we can implement in years to come as opportunities become available. This was a fantastic help to us, and also the review of codes and ordinances was very important. So the outcomes of that, the biggest outcome was we got a great document, Green Infrastructure Implementation Strategy for the City of Clarksville. It's a guidebook for the next 5 to 10 years on what we can do to continue to evolve and grow into better stormwater management. We're going to do a better job on our local codes to make sure they're green infrastructure friendly. We've talked about the potential for a stormwater utility. Stormwater infrastructure has costs, just like water and wastewater infrastructure do. And just like we pay a water bill every month, we ought to get used to paying for the stormwater things that really need to be done to protect water quality. The final one there, more people get it. We no longer have to explain what stormwater is when we go talk to city staff or the mayor and council right off the bat. They get it and they're advocates for it, and we're disseminating that information across the community. Finally, some recommendations for those of you who may be considering or are already somewhere along the way in this process. Education is vitally important, just like I mentioned about staff and the local elected officials. You've also got to be opportunistic and adaptable. Things pop up you may not have ever foreseen. For example, the buyer retention area outside of the local business, and you got to be ready to jump on those things when possible if funding allows. Also, don't be afraid to steal good ideas. There are people doing fantastic work nationwide out there on green infrastructure. This isn't reinventing the wheel, and not everything works in every community. It's a case-by-case basis, but take good ideas from what other people are doing and adapt them to what you need to achieve in your community. Enhance what you're already doing, and look at the EPA's Municipal Separate Storm Sewerage System Phase 2 guidance. There's some really good information there that can help you enhance what you're already doing, particularly as it involves post-construction runoff control and illicit discharge detection and elimination. I wanted to say one final word while I've got a captive audience. If any of you are still left out there, I can no longer see the number on my screen. You may have dropped off by now, about stream bank restoration. Restoration is very expensive. I'm somewhat torn on it. I recognize the need for it, but I also recognize that an ounce of prevention is worth a pound of cure. You can see we had a badly eroded stream bank, mass wasting. This stream is called Rocky Branch. It's a tributary to the Sequoia River. At this point, it should be called used to be Rocky Branch because of all the stormwater impacts and the bank erosion that's occurred. There's an overhead transmission line here, so very little deep-rooted riparian zone vegetation. A lot of runoff into this stream from upstream development, has exacerbated this bank erosion problem, and it had receded laterally about 10 feet over the course of just a few years. So we were able to, again, with some grant funding and also some work from city staff, use a natural channel design from the North Carolina State University Bio and Ag Engineering program, Jason Zink and Greg Jennings in particular. And we were able to reshape this bank, reconnect it to a small floodplain terrace, put in some structures in the stream to help to dissipate the energy as the stream flowed down to the Sequoia River, and get some vegetation back in there. It had to be low growing because the monopolistic utility would come whack it down, but we get some stuff in there green with roots, and man, that's green infrastructure, and that's helping hold the structure of those banks in place. So increasing buffers, better stormwater management would go a long way towards preventing these types of problems before they become so expensive to fix. Mercifully, y'all, that is my last slide. I would like to thank the U.S. EPA for the opportunity to be on this today, and also for the ongoing Clean Water Act 319 funding. Also the Georgia Environmental Protection Division for their assistance with these projects. Tetra Tech, I already mentioned, the Ecological Planning Group, and the City of Clarksville, staff, mayor, and council, and our good friends down the road at the City of Cornelia, who have done a whole lot to support these programs and are doing great things in their community as well. Thanks for the opportunity to be here today, and I think I will pass it on back over to Emily now.
Thank you very much, Duncan. That was a great presentation and really impressive pictures there at the end about the restoration. In the interest of time, I think I am going to pass on the question and answer. I apologize for the delays earlier. I am going to bring John and Dan back on, just if you guys have any last comments that you'd like to make. What I will do is send out all the questions that were asked by the audience to our speakers, and so they can follow up with you if they'd like. Again, I just appreciate everyone being on today. So any final comments or thoughts from our panelists today?
No, just thank you for the opportunity.
Okay, well, I'm just going to go ahead and show the speaker contacts we have here. And again, we'll post the slides and or a recording on our website within a few weeks. And I just want to put it in a plug for our 2016 series, which will start, I believe, in February. So again, I just want to thank Dan and John and Duncan for joining us today, and all of our participants for listening in, and all of our participants who have joined us for the 2015 series. It has been a great year. We had a lot of great topics and great information that we got to share. And just again, as a reminder, the presentations will be available on our website, www.epa.gov/green-infrastructure within a few weeks. I just want to wish everyone a Happy New Year, and this ends our webcast for today. Thanks for joining us.
Thank you.